Howdy. There has been a quake near Helsinki in Finland, near Espoo. 3.25 hours ago. And the depth under the epicenter is 11 kilometers, which is interesting because very often they don't tell us anything about the depth. The main data source is Raspberry Shake and not Norsar. So now let's just try to remember this area here. Maybe we switch to terrain, it's easier. Maybe not, I don't know. Because the interesting thing is that also today, approximately at the same time as the quake was, 25,000 households had electricity in Espoo. Had no electricity in Espoo. Accidents, yeah. There hasn't been any electricity. The situation is returning to normal. If you read it like that, 25,000 households had electricity in Espoo. The situation is returning back to normal. You could probably think that, yeah, they take it off again, the electricity, and they go back to normal. But there wasn't electricity. The power outage affected the western parts of Espoo. As a result of the situation, the shopping center in Espoo and Lahti was emptied for customers. According to Caruna, the power failure started around 1 o'clock in the afternoon. In Espoo, on Tuesday afternoon, more than 25,500 households had a power outage. By 5 p.m., the situation has returned to normal according to the electricity distribution company Caruna's disturbance map. On Tuesday, there was an extensive power outage in the areas of Souka, Laurinlahti, Esponlahti, Kivenlahti, Saunalahti, Nöykkyö, Tillimäki, Latokaski, Kurtila ja Vanttila. We received an information about the power outage about 12:55 p.m. It is a fault in the 110 kilovolt network. A more detailed investigation of the fault is underway, says Caruna Operations Center Manager Kimmo Vainiola in the press release. Jürgen Dahlquist, Caruna's Director of Operations, said after around 2 p.m. that the cause of the fault is unknown. Electricity is currently being restored through backup connections. According to Dahlquist, at the time it was still too early to estimate when electricity would be restored to everyone. This won't last until the evening if something completely surprising doesn't come up. So this is the map which I told you to try to remember. Because so obviously the red area is where the biggest outage has happened. And here it says Espoo and Helsinki. Going back to the earthquake application map, the area we just watched is somewhere here. There's this bridge, and you don't have to go too far. And you find the quake location. Let's go to satellite pictures. And there is a golf facility there with a lake. I don't know what that is. There is something in the lake. I have no idea. But anyway, we won't dive too deep into that because it might be boring. I just find it interesting that it's not very often that we get something like a 3.2 in Finland. And it's not very often that there is some rather big power outages in Finland neither. There hasn't been any like real solar activity or geomagnetic activity or whatsoever, any storms. Just a quake and a power outage. Which might be just a coincidence. But I think they could be very well related. Let's see if they figure out what was the reason for the power outage. Now let's go to something completely different. I think we have to talk about mountain water, wide rivers, glaciers, cryptodomes, and cryptogeysers. That's the playlist. And there are many videos. 359 about the topic mountain water. And in a nutshell, the whole paper talks about that glaciers might be lava streams made of water, which would mean that the glacier-carrying mountain would be a volcano, which seems to erupt mainly by water, or mud, and mud, much water and mud volcanoes, and might be these kind of cold volcanoes. But there are also hot ones, like mountains with glaciers on top, and there is like hot lava coming out. But it's not necessary. The reason why I wanted to talk about that is I stumbled across an article and I just read the first few lines. I didn't have really time to dive into that, but it seemed related to this topic and seemed to be very interesting. So let's go over and take a look at that. Yeah, and it seems I have been a little bit hasty with this. I have no idea what kind of page this is. Mint Premium, The Economist. Glaciers on volcanoes could serve as an early warning system. Glaciers on volcanoes. Because it turned out that's just for subscribers. But anyway, let's just read what we can read. View of the Villarrica volcano as seen from Villarrica, some 800 kilometers south of Santiago de Chile, on September 27, 2023. Yeah, just a few days ago. Fire and ice. Summary. They could also skew measurements of climate change. Mapping glaciers was once a difficult and arduous job. So was monitoring volcanoes for the grumblings and rumblings that might herald an eruption. In recent decades, the old methods of hiking boots and mountaineering gear that's really annoying, have been joined by satellites and remote sensing, making things both easier and safer. But looking from afar has its drawbacks too. If a volcano is high enough to spot glaciers on its flanks, and many are, then the thick layer of ice can make it harder or impossible to get accurate temperature readings from. Yeah. That's a pity. Maybe there is some other article about this somewhere, but I think I'll leave it here because, this didn't really work. Glaciers on volcanoes could serve as early warning systems. Yeah. Like they are well aware of this danger. For example, in Iceland, where they are expecting always these kind of floods before a volcanic eruption because the ice starts to melt. But anyway, a quake, a power outage, and something about glacial volcanoes. Yeah, I think I'll leave it here. There would be a bunch of other things too, but yeah, maybe next time. Thanks. Bye.